In this episode, we start by focusing on a skill that sounds simple but is surprisingly hard in real life: being able to find where cardholder data exists, even when it is scattered, duplicated, or hiding in places nobody planned for. Beginners often imagine cardholder data as something that lives neatly in a payment database or moves through a checkout page and then disappears. The reality is that data has a habit of sticking around in logs, emails, spreadsheets, screenshots, support tickets, backups, and third-party systems that were never designed to be part of payment processing. When you can confidently hunt for cardholder data across an entire environment, you protect people from exposure, you protect organizations from risk, and you make every later PCI decision more accurate because scope becomes based on evidence instead of guesses. This skill is also empowering for new learners because it turns security from a vague fear into a practical question you can investigate and answer. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A good place to begin is by defining what you are hunting for, because people often lump together different types of payment-related information. Cardholder data usually refers to the primary account number, PAN, which is the long number on the front of a payment card, and it can become sensitive in different ways depending on what it is combined with. There is also something called sensitive authentication data, which includes things like the magnetic stripe data, the chip data, and the card verification code, and that category is treated as extremely restricted because it can enable fraud if mishandled. Beginners sometimes think any reference to a customer or an order is the same as cardholder data, but PCI is very specific about what triggers strict requirements. The practical lesson is that your hunt is not just for obvious payment records, but for any place the PAN or restricted authentication elements might appear, especially in raw form. When you can describe exactly what you are looking for, you stop wasting time chasing unrelated data while missing the truly high-risk pieces. It also helps to understand why cardholder data spreads, because that explains where to look and what patterns to expect. Data spreads because systems copy information for convenience, such as caching for performance, generating receipts, creating support case records, or writing debug logs when something breaks. Humans spread data too, because people paste numbers into chats, take screenshots to show an error, or save a file to work on later without realizing it contains sensitive fields. The environment can also spread data through automated processes like backups, replicas, exports, and analytics pipelines that collect everything they can. None of this requires bad intentions. It often happens because people are trying to solve a problem quickly. A strong data hunt assumes that convenience and troubleshooting create duplication. So you look beyond the official payment systems and into the places where work gets done under pressure. A core beginner concept is learning to think in terms of environments, because cardholder data can exist in more than one place even within the same organization. Production environments are the ones that handle real customer transactions, so they are an obvious target for the hunt. Test and development environments are just as important, because people sometimes copy production data into them to test a bug, and that creates a hidden, uncontrolled pool of real card data. Training environments can also be risky when they use real examples, and even personal devices can become part of the problem when people email themselves files or store screenshots. The point is not to accuse anyone, but to accept that data can drift into places where controls are weaker. When you hunt cardholder data, you treat every environment as potentially contaminated until you have evidence that it is clean or that the data is properly protected. To hunt effectively, you need a mental map of the kinds of places data can live, starting with structured data stores like databases. In a database, cardholder data might be stored in tables designed for payments, but it can also end up in unexpected columns like notes, metadata, or free text fields that were meant for descriptions. Data can also exist in exports, like reports generated for finance, chargebacks, or reconciliation, which may be saved as files and shared broadly. Another hiding place is search indexes, which can ingest data from multiple sources and make it easy to retrieve, which is great for productivity but dangerous for sensitive fields. Even if a primary database is well controlled, These secondary stores can leak the same data into places with weaker access control. A careful hunt treats the main system as only the beginning, then follows where that system sends data for business reasons. Logs and monitoring data are a major environment category that beginners often overlook because they do not feel like data storage in the same way a database does. When an application processes a payment, it may log requests and responses, error messages, or debugging details, and those logs can accidentally include the PAN if developers were not careful. Web servers, application servers, and network devices can log traffic metadata, and sometimes that metadata can include sensitive fields if they appear in URLs or form data. Security tools can also collect information for analysis, and if they ingest raw transaction payloads, card data can travel into systems that many administrators can access. The risk here is that logs are often retained for long periods and copied to centralized platforms, which means one mistake can spread sensitive data widely and persistently. A strong hunt always includes a careful look at what gets logged, where logs are stored, who can access them, and how long they are kept. Files and documents are another category where cardholder data frequently appears, especially in organizations that rely on manual workflows. Spreadsheets used for reconciliation, text files created during troubleshooting, PDFs of receipts, and screenshots shared in messaging tools can all contain card numbers without anyone meaning to create a sensitive artifact. Support tickets and customer service transcripts can also capture card data if customers type it in or if staff copy it while trying to help. Email is a classic risk channel because it is easy to forward and hard to fully control, and attachments can persist in mailboxes for years. The hunt mindset here is to assume that wherever people communicate or collaborate, sensitive information might appear. When you view collaboration tools as potential data stores, you expand your search beyond the technical payment system and into the everyday places where mistakes happen. Backups and disaster recovery copies are especially important to include in your hunt because they multiply the impact of any other data location. If cardholder data exists in a system, it likely also exists in that system's backups, replicas, snapshots, and archival storage. Beginners sometimes think deleting data from the main system solves the problem, but backups can preserve older versions for a long time. This matters for scope and risk because backups are often stored in separate locations, sometimes managed by different teams or vendors, and sometimes accessed during emergencies when normal procedures are stressed. A strong hunt asks not only where data is today, but where it was yesterday, and whether copies exist that can be restored later. When you understand backups as time machines for sensitive data, you realize why controlling data sprawl is so important. Third-party and cloud services introduce another layer, because data can flow into platforms that the organization does not fully control day-to-day. Payment gateways, fraud detection services, customer relationship systems, analytics platforms, and help desk tools can all receive or store payment-related fields depending on how integrations are built. Beginners sometimes assume that if a vendor is involved, the vendor automatically handles security, but the real question is whether the vendor is receiving cardholder data at all and what responsibilities are shared. Data can also leak into third-party systems indirectly, such as through logs shipped to a managed service or through files uploaded to a collaboration platform. The hunt skill here is to look at integrations and data sharing paths with the same skepticism you apply to internal systems. If data crosses a boundary, you need to know it, document it, and ensure protections follow it. As you hunt, it helps to recognize the difference between intentional storage and accidental storage because they require different responses. Intentional storage might include a database that stores the PAN for a defined business reason, and that storage should be designed with strong protections and strict justification. Accidental storage might include a log entry that captured a full card number because of debugging, and the best response is usually to eliminate that behavior and clean up the stored copies. Beginners sometimes try to treat every instance the same way, but good judgment means asking why the data is there and whether it needs to be there at all. If it does not need to exist, removing it and preventing recreation is often the most powerful security step you can take. This connects directly to PCI ideas about minimizing data and reducing scope, because the easiest data to protect is the data you never keep. Another beginner-friendly way to think about data hunting is to follow the life of a transaction like a story, because stories reveal where data might appear. A customer enters card details, the system validates and sends them. A response comes back, and then records are created for receipts, accounting, customer support, and fraud review. At each step, ask what information is captured, who sees it, and where it is stored. If a step involves troubleshooting, ask what gets copied into tickets or logs. If a step involves reporting, ask what gets exported and emailed. This story approach keeps you from focusing only on the technical core and forgetting the surrounding business processes where data is often exposed. Finally, you should understand that hunting cardholder data is not a one-time activity, because environments change and new data paths appear over time. A new feature, a new vendor, a change to logging, or a new report can create a fresh place where card data appears. People also change, and new staff might repeat old mistakes if expectations are not clear. The habit you want is to treat data discovery as a regular part of keeping scope accurate, keeping controls effective, and keeping risk from quietly growing. When you build that habit, you become someone who can protect an environment even as it evolves, which is exactly the kind of thinking PCI expects. By the end of this lesson, the big takeaway is that finding cardholder data is both a technical and a human problem, and you have to think broadly to do it well. You are looking for specific sensitive elements like the PAN and restricted authentication data, and you are looking across databases, logs, files, backups, and third-party systems where data can spread through convenience and troubleshooting. You are also learning to separate intentional storage from accidental leakage so you can reduce risk at the source instead of just piling on controls. When you can hunt data confidently, you make scope decisions more precise, you reduce surprises during assessments, and you build a safer payment environment for everyone involved. Most importantly for exam readiness, you start seeing PCI as a connected system of responsibilities, boundaries, and evidence, rather than as a pile of rules to memorize.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.